In this video, what we're going to do is take this function of two variables and we're going to find and classify the critical points. So first off, we're going to find the critical points. So this is where the gradient of this function is going to be equal to 0. So that means I need f sub x and f sub y equal to 0. So f sub x is 2x plus 12 plus y, while f sub y is x plus 2y. These are both set equal to 0. So at this point you typically have some algebra. So you have two equations and two unknowns that you need to solve. I'll use substitution here. According to the second equation, x is equal to negative 2y. Plugging that into the first equation, we're going to have 2x, which is actually negative 4y, plus 12, plus y, equals 0. That's negative 3y plus 12 equals 0. So that means that y is going to be equal to 4. And if you plug that in, we get x is equal to negative 8. So we've got a point. Fantastic. That's our only critical point. You will have functions that have several critical points. So now we want to classify. Now this is where we're going to be using the discriminant d, which is equal to f sub xx times f sub yy minus f sub xy squared. So let's see how this is going to work. F sub xx, well, thank goodness I have my derivatives above, so that is going to be equal to 2. F sub yy, the derivative of this with respect to y, is 2. And f sub xy, well, you can take either one of these and differentiate according to the other variable. So the derivative of the first line with respect to y is 1. That's what you get if you differentiate this line with respect to x. So we have d equals 2 times 2 minus 1 squared. That's 3. Sometimes this will be a function of x and y. Here's what's important. That's positive. So here's what happens. If d is greater than 0 and f sub xx is greater than 0, and of course what I mean here is at the point that I'm interested in for negative 8, then our critical point, excuse me, I should have reversed that, negative 8, 4 is a local min. In other words, we only get local maxes and local mins when d is greater than 0. And you can look at the sign of the second partial with respect to x, concave up. That tells us local min. Alright, here's one example. I would highly suggest, if you're looking this over, to look over the rules for d. We've just used one possibility here for d. There are actually 3 other possibilities that you need to focus on so you understand all the rules for finding and classifying critical points.